Hello and welcome back to another video for O-level math. We were doing the chapter on sequences and patterns. Okay, we've talked about linear sequences. I've told you all the formulas that are relevant. So that is done. Now let's talk about special sequences. Okay, so what are these sequences? These are the sequence of square numbers. Okay, very important to know what these square numbers are and how they work. Then cube numbers, you should be able to spot them when you see one of these numbers. So it's important to sort of remember the series rather than trying to figure it out on the spot. So cube numbers, cubes of 1, cube 2, cube 3, cube 4, cube and so on. Okay, triangle numbers are also called quadratic sequences. Okay, we'll talk about these in detail later on. Okay. Then there are prime numbers. I think we've spotted prime numbers before, so we'll see those again in a bit. Okay, this is the first five terms of a sequence, or 17, 11, 5, -1, -7. So I can clearly see there's a -6, -6, -6. So this looks like a linear sequence. Okay. What about linear sequences? It says find in terms of n, an expression for the nth term. We've talked about this before. So nth term is basically a plus t times n minus 1. That's a is the first term, 17. Common difference is -6, so we have n minus 1. So that's 17 minus 6n plus 6. So we have 23 minus 6n. Okay, then let's go to part B. It says the nth term Sn of a different sequence is found using the formula this, where the first four terms of this sequence. Okay, so first four terms. Okay, so the nth term Sn of a different sequence. So this is just first term, so 3 times 1, that's 4. S2 is 2 square plus 3 times 2, that's 10. S3 is then 3 square plus 3 times 3, which is 9 plus. This is a paper 2 question, so you are allowed a calculator on this. I think maybe I can also use a calculator. Okay, so there's a difference in codes. If you're doing an IGCSE exam, this is not an IGCSE exam. This is a 4024 O-level math GCE paper. The structure is the same. It's just that you have different numberings for the paper. So I get 18 from this. And when you have S4, that's 4 square plus 3. That's 16 plus 3, 28. Okay, it says work out the first four terms of the sequence. That is what I have. Then it says the nth term of another sequence is found using the formula Tn equals to 5n minus 12. So Tn equals to 5n minus 12. The two values of n for which Sn over Tn is equals to 6. Okay, that's interesting. Form and solve an equation. So I've told you everything about Sn. So that's n squared plus 3n over 5n minus 12 equals to 6. So the next thing that I'm going to do is I'm going to cross multiply. So I get n squared plus 3n equals to 30n minus 72. 6 times 5n is 30n, and 6 times 12 is 72. I think a quadratic equation seems to be emerging. Let's talk about that. N squared minus 27n plus 72. So then I can go ahead and, since it's a paper 2 question, I know I can use a calculator to solve this. So what I'm going to do is I am going to use my calculator and get to the final answer of this. Okay, so minus b plus minus root of b square minus 4ac over 2a. So what do I get? I get 27. I have to show you the working on this one. So let's just calculate. That's 27 squared minus 4 into 1 into 72. It's 441, so that's 27 plus minus 441 over 2. The root of 441 is, I think, 29 or 21. 21 square is 441, right? So that's 27 plus 21 over 2 and 27 minus 21 over 2. So there is 48 over 2, which is 24th. The 24th term or the third term. Okay. So finally solve in terms of n, find these two values. So n is either 4, sorry, 3, or n is 48, 24th, right? 24. Okay. So those are the two values of n uh, for this situation. Let's talk about the next question. The next question says the nth term of a sequence is 7 minus 2n. Write down the 23rd term in this sequence. So let's see, this is again a calculator paper. So 7 minus 2 times 23rd. What do I get? So I get minus 39. Okay, then I have the first 5 terms of another sequence, or this 4, 7, 10, 13, and 16. Write down an expression in terms of n for the nth term of this sequence. So let's see what sort of a sequence do I have. I think this looks like a linear sequence. So that's plus 3, plus 3, plus 3. So that's a linear sequence. I know that the term number n for a linear sequence is a plus d times n minus 1. So I'm going to say 4 plus 3 times n minus 1. So that's 4 plus 3n minus 3. 3n plus 1 should be my final answer for this part. Then part 2 says the first 5 terms of another sequence. Now in this numerator, I see that this is the sequence that was here. What do I see in the denominator? I see a sequence of squares. Do you see that too? Write down the next term in this sequence. Okay, let's find out the next term. So the denominator has got to be 36. And since 3 was being added, so that should be 19 over 36. It says write down an expression in terms of n for the nth term of the sequence. And this is relatively simple. Since I just see a sequence of squares, the numerator is final. It's 3n plus 1. That's what I found in the earlier part. Since it's a sequence of squares, I can just say that the denominator should be n squared and nothing else. Okay, that brings us to the end of this question. Let's see, we have another question before we go on to quadratics. Yeah, there's another question before we go on to quadratics. That's probably going to be a separate video for you. Each diagram in the sequence below consists of a number of dots. Okay, diagram number 1 is that many dots. Okay, write down the value, please. I need to count the number of dots actually. So that's 1, 2, diagram number 4, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 on this side and 9 on the other side. I think it should be 19. Okay. And then I don't have a pattern right now. So that's plus 4. That's plus 6. It's plus 8. So that should be plus 10. So 29 plus 10. 19 plus 10 should be 29. The Q is 29. Just have answers for the marks for the correct answer. Nothing unusual about it. I think this is also a calculator exam, so we should be able to use a calculator. Let's see, this is another sequence. Looks like this. Okay, so 1, 4, 9. So this looks like a sequence of squares. So 1, 4, 9, that should be 16 then, 4 square. I can also count these dots if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's in a square. You can also see that happening. 5 square should be 25. And if I were to tell you this should just be n squared. Okay. Then it says another sequence whose nth term is un equals to n minus 1. Un is equals to tn minus sn. What is tn? Tn was here, I think. Okay. So the first term is 0. The next term is 1. The second term is 2. Okay. Evaluate u4 and u5. So that's 19 minus 16. So that's 3. And then I have 29 minus 25. That's 4. So the sequence is just 0, 1, 2, 3, 4. Okay. The next should be 5 and so on. Can I express un? So this looks like a linear sequence. I'm going to write a plus d times n minus 1. Okay. So a is 0. What is the common difference? That's that. Well, that's basically just n minus 1. I think my screen seems to have frozen. Okay, so just n minus 1 then. Let me just write that down properly. N minus 1, because it's just 1 n minus 1. It says hence using your expression for Sn, find an expression for Tn in terms of n. Okay, so I can do that too. Since un was just Tn minus Sn, I have an expression for un that's n minus 1. I don't have an expression for Tn. And what was the expression for Sn? It was already given to me. I just found that out. That was n squared. I can just say that's n squared. So for Tn, I can just say that I want to move n squared to this side. And I have Tn. Okay. So it was a question leading you to the answer. Basically, nothing unusual about it. I hope this was a productive video for you. I'll be back with another video soon. Please make sure that you subscribe. I will also be posting some worksheets that you could solve to strengthen your concepts. Thank you for watching.